of the internet. Welcome to another episode of Constant Science. I'm Don from Explosions Incorporated. My voice seems to have pretty much recovered from the long-term bug I've had for the last couple of weeks, so I thought I'd do another video today. And it's going to be a video that covers an idea I had way back when I did my video on the basics of chemistry. So basically, chemicals are everything. I'm going to call it minute chemistry, because here's the idea. I'm going to try over the course of time in a number of different videos to tell you just a little bit about every single element in the periodic table, and I'm going to give myself a minute to tell you some relevant facts about each and every one of those elements. Before we jump in though with hydrogen, number one, I thought we'd cover some basics of chemistry, some terms and concepts you'll need to know to kind of parse every single element we're going to talk about. Okay, first of all, the basic component of matter in all of its elemental forms on the periodic table is known as the atom. The atom is made up of 3 subatomic particles, which can break down into other ones, but let's not talk about that. That gets a little complicated. Those 3 particles are the proton, the neutron, and the electron. Protons and neutrons live in the nucleus in the center of the atom. Electrons orbit that nucleus in what we call different energy levels, or orbitals inside the electron cloud. Different energy levels can have different numbers of electrons before they're maxed out, and any further electrons have to go into a higher energy level. This is the periodic table tile for element number 1, hydrogen. You'll notice a number in the upper right corner and one at the bottom. The upper right corner is the atomic number. This goes up in order, and it represents the number of protons and electrons in a standard atom of that element. Doesn't show the number of neutrons because the number of neutrons actually varies. You have the standard atom, which has a certain number of neutrons, and then any other atom that has a different number of neutrons from the standard atom is called a different isotope of that element. Down at the bottom, that is the atomic mass of the element. It's measured in atomic mass units. A proton or a neutron each weigh 1 atomic mass unit. You will notice, however, that that is a decimal. It has nothing to do with electrons. They do have mass, but they are so small as to be negligible, we don't really count them. The atomic mass number is actually an average. It averages out all the different isotopes and their masses based on frequency. So if you have a 90% frequency of hydrogen in its normal state, which, you know, a lot of hydrogen is that, and then smaller frequencies of its 2 stable isotopes, deuterium, which has 1 proton, and tritium, which has 2 protons, you're going to end up with an average slightly higher than 1, which is what you see at the bottom. Okay, that's pretty much everything I think you're going to need to know. Protons, neutrons, electrons, atoms, isotopes, energy levels, and orbitals and stuff like that. All right, here we go. Number 1, hydrogen, 1 proton, 1 electron, 0 neutrons. The most abundant element in the universe, though not too abundant here on Earth. You may be familiar with it outside its elemental form, however, because it is in all sorts of compounds you may be familiar with. Carbohydrates like sugar, hydrocarbons like alcohol. It's what makes acids, and you may recognize it also from H2O, otherwise known as water. Hydrogen has many uses. Aaron and I use it to create explosions like this one. Because it's less dense than air, it used to be used in things like dirigibles and blimps until it created an explosion like this one. It's used as a processing ingredient in manufacturing petroleum products, and some people think it could be a good fuel, but we'd have to build a hydrogen economy first, and that might be prohibitive. And the atomic structure of hydrogen is also the logo for Dr. Manhattan from Watchmen. Most importantly, hydrogen is the primary ingredient in the nuclear fusion that occurs in the sun that gives us all of the energy we need for life to actually exist on this otherwise cold floating ball of rock we call the Earth. Number 2, helium, the second most abundant element in the universe. Most of it was actually formed in the first 1 to 3 minutes after the Big Bang. It is the product of helium fusion in the sun. It gives us the energy that we need by being fused out of hydrogen. Because its outer electron shell is full, it can't borrow or give electrons to anyone else, or rather it doesn't want to, and so it rarely forms compounds, only under very extreme circumstances, usually that happen in lab or in the hearts of stars. It has many uses as well. We use it in balloons most frequently. Because it's non-reactive, it doesn't form compounds, it will not explode and create explosions like this one. Its biggest use is actually in cryogenics, cooling down the superconducting magnets in MRI machines in hospitals. Number 3, lithium, the first of the alkali metals. It's highly reactive. Its outer energy shell only has 1 electron instead of, maximum full out, so it wants to give that electron away to other things, but it is the least reactive of the alkali metals. It reacts in water like all of the alkali metals. It explodes like this. It has lots of different uses. You can use it in batteries, regular batteries, or rechargeable lithium-ion batteries like this one. Salts of lithium are used in fireworks because they combust with a red glow. That's pretty neat. And it's also used as a drug to treat psychiatric disorders, and because of that, it was the subject of a really great Nirvana song called, of course, Lithium, about getting fake happiness by finding religion. Number 4, beryllium. It's fairly rare because it's formed through what's called stellar nucleosynthesis in the hearts of stars, the same thing that turns hydrogen and hydrogen into helium, also forges heavier elements. It's also never found in its elemental state in nature. It's only found in compounds. One of the most famous and familiar compounds of beryllium is the emerald, which is a compound of beryllium, oxygen, aluminum, and silicon. Despite its relative rarity, it has some utility and some uses. It's very transparent to X-rays, so it's used as a window in X-ray detectors and X-ray microscopes and stuff like that. It's non-magnetic, completely non-magnetic, and so it's used to defuse naval bombs and mines under the water because they often have magnetic fuses. And finally, it's a really useful alloying agent for things like copper and steel. Number 5, boron. Also relatively rare because it's only actually formed when cosmic rays bombard other matter. It's not formed by nuclear synthesis either in the hearts of stars or even in the hearts of supernovas. A lot of elements are formed that way. Boron isn't one of them. That's pretty neat. In its pure form, it's only found in meteoroids. It's found in lots of different compounds here on Earth, and despite its relative rarity, it actually has some uses. For example, you can make borosilicate heat-resistant glass out of it, also known as the brand name Pyrex. Aaron and I use borosilicate glass in almost all of our lab equipment. Boric acid can be used as an antiseptic, and boron is actually an ingredient in some new cutting-edge anti-cancer drugs, but you may be most familiar with it as an element of sodium tetraborate, otherwise known as borax, that we can use as laundry starch. So there we are, the first episode of Minute Chemistry. I'm surprised I actually managed to keep myself to less than a minute on every single one of them, though I was kind of pushing it with hydrogen there. So we'll see some more of these. I'm going to try to cover 5 elements in order with every Minute Chemistry installment, and that's not to say every single video I do from now on is going to be Minute Chemistry. I'll pepper it with other stuff too, but this is going to come up from time to time. I hope you dug it, and as always, if you have any other cool ideas for stuff, drop them in the comments. Thanks for watching. We'll see you next time with Constant Science. I'm Don from Explosions in the Corporate.